So, hello everyone. Hope you guys are doing great. Today, I am going to show you how to do the fine tuning of the Google BERT model. And later on, I'll show you different version like digital BERT and Alberta, how we can achieve these things. So, BERT is the encoder based network, bidirectional encoder based network. So, what it does basically, this problem statement is in the Twitter while the COVID was going on. So, that time in Twitter, there is a lot of conversation was going on. So, it's all about that what are this conversation is falling under which category, like it's a positive conversation, negative conversation, extremely negative, or natural conversation. There are different categories are there. If you want to see the conversation type, then I can show you. So filter options. So just a minute, let me show you. So you can see there is a total around 5 levels are there: positive, negative, natural, extremely positive, extremely negative kind of thing. There is a different filters are there. So these conversations are falling under which category? It might be it's a human labeled data, and you will get this data. I will post this data link over the video description, so you guys can go ahead with the collect the data set. Okay, so that's all about the data set. It's just to identify. It's a kind of multi-class classification problem. So without wasting time, let me note, or let me create a notebook for you how to we can do the training, and then in the next video I will show you how we can start the predictions. Okay, so just before that I have to import some libraries. Let me import these libraries because I am building this model on the TensorFlow, not on the PyTorch, but you can do on the PyTorch as well. So it's a version of 2.9.2 TensorFlow. So I just install all the sort of things, and then I'm gonna create some functions which will be responsible to convert your utterance into attention mask and label encoder input IDs. Because if any sentence will have the two part in case of BERT, and these are the things how we are going to convert. These I have already explained in my previous video. You guys can check it out. My previous video, I'll give the description link as well. And then just we did that, and next what we are trying to do, we are just trying to do some kind of pre-processing of the data. So let me do the pre-processing as well. So what is the pre-processing we are going? I'm not going to create a more statistics here to see the data and do the pre-processing. I'll do a simple pre-processing. What I felt like many utterances are there which having only one intent. So I want to remove those utterances which having only one intent. So you can see I have total data set length is 41157, and that I want to remove those data set which having only one intent. So you can see the one utterance which having only one intent that I have removed, and afterwards it's this. And now what I'm trying to do, I am trying to create attention mask and IDs here. So 512 is basically highest length of the sentence will be 512. These are then a number of samples 700 I haven't taken. 700 foot will fall into the train, and then these other things will be there. So let me execute these things, and then I'm gonna create one label encoder. Label encoder for what? Because if you can see my DF, if I'll show you the DF, there is in expected column, it's kind of label. So machine will not understand this label. We have to do the label encoding for this. So for that, I'm going to do label encoding, and I'm going to use sklearn pre-processing label encoder here. So this will, what it will do, it will encode these utterances with some encoder. So if I'll show you, see, you can see train data sample is 700 because I haven't picked this 700 only. You can pick the like 4000 or something. I would like to go with the higher data. So that will be great, or else 30,000. I can go with the 30,000. That's a good number, I think. So you can see this train data is there. And now if I'll show you the DF, now you can see we have one more column. This is the encoded intent name, and the column also natural has been encoded as a 3, extremely negative has been encoded 0, positive has been encoded as 4. So encoder number. Now on going forward, we'll use that part. So now I would like to show you label codes as well. Oh, sorry. So if I will show you this part, then you can see the encoded, expected, encoded. Can you see this? Extremely negative, it's encoded as 0. Extremely positive has been encoded as 1, and negative has been encoded as 2. Natural is encoded as 3. Positive has been encoded as 4. Now I would like to show you a few more things. So now if I would like to add a tokenizer, and what tokenizer does, it's already explained in my previous video. Please have a watch on that, have an eye on that. That will be more sensible, because that there I haven't explained very depth. So this function, this you can say, this block is just doing downloading your bird base uncase. Uncase is basically that will not decide like what is the case and type of the data. So it's a bird uncase tokenizer I'm gonna download from the Hugging Face library, and then I'm trying to convert my whatever sentences are there into two part. One is the input IDs, another is the attention mask. These are the things I'm trying to collect, because these are the things is important. Okay, so next I'm gonna do what I'm trying to do. I am trying to do a kind of shuffling and then just preparing the data, and then we are just deleting the data set as well. We just convert, split the data set into train and test, and then we are good to go. And then now we are going to start a training procedure. Let me start a training now. So for this block, train the model, I'm trying to do the training part. And in this block, what I'm trying to do, control A, I'll write a training code here. So what I'm trying to do, first of all, I'm gonna call my pre-trained tokenizer, which is this, and here from pre-trained bird case, and then on top of that, I'm gonna add the layer of input IDs and attention mask. So these are the two layer I have been added here. And then I'm gonna add the embeddings layers, because embeddings is basically like you are going to dimensionalize and channelize your data. Okay, so these are the embeddings we have been added. Then I have added the X and Y and the model and the model layer, and then we are going to call the optimizer and loss and accuracy here. And at the end, I'm gonna call everything in one function. So I have created the optimizer and loss and accuracy, these things. And now next point, what I'm trying to do, I'm trying to call compile the model, and then I will show you the summary. It's a pre-trained model, just I loaded. I have now I on top of that I added my embedding layer. You can see this embedding layer has been added on this, and it's a soft mix. Because why soft mix? Because we have a binary, it's a multi-class classification problem. That's what is the soft mix. And you can see trainable parameter is around this much. Okay, so it's a very huge parameters, right? So now what I'm trying to do, I like to start my training procedure. So let me start my training procedure. So it will start a training, and it will take some time. You can see it's a BERT model, it's a very huge model. I am training on my CPU, so it will take some time. So you can see the complete processing training process has been started. And now what I will do, what I can do here, I'll pause this video for a while. To be honest, like it will take some time to train, because it will one epoch, it will take around 18 or 20 minutes, 18 to 20 minutes to train, and second epoch will take another. So obviously your model, you can see expected time, it's given like 13 minutes. What is that? ETA like around 30. Okay, yeah, it will be 13 hours something. Why? Because I haven't added. That's what I added at 700 data only. Okay, so here I have added 30,000. That's what it taking this much of time to do the training. Okay, so 13 hours I have to utilize my CPU, but obviously I'm not gonna train with this much of data. I would like to, for the demo purpose, I would like to make it 700 so that I can complete it out. So this is all about the training, guys. In the next video, I will show you the predictions pipeline, how we can do the prediction. And then at the end, I will create a framework, and I will try to Dockerize the entire thing so that you can make it productionize everything in a production grade level of code. So this is all about this video, guys. Thank you for watching it. If you really like this video, please do subscribe the channel so that you never miss the update. Thank you.